Hello guys, welcome to my YouTube channel. Today I am going to explain anonymous inner class versus lambda expression. So what is a anonymous inner class and lambda expression? I have already explained on my previous chapter. Okay, so lambda expression, why we are using we for implementing the functional interface representation, we are using a lambda expression. It is a representation. Okay, there are some rules to how to write a lambda expression. I have already discussed in my previous chapters, so please go and watch my previous chapters. So now today's topic is anonymous inner class and the versus lambda expression. What is an anonymous inner class? So anonymous means nameless. The class have which have no name. Nameless class is known as anonymous inner class. Okay, just like as the class, or we can say interface as well, or uh, annotation or enum defined in another class interface annotation or enum is known as inner class. Okay, so that is a inner class, and anonymous inner class means nameless class. So whenever we are using an anonymous inner class, there may be a chance of using a lambda expression to reduce the length of the code and resolve complexity. Okay, so whenever we are writing a anonymous class, so there might be a chance again we can use a lambda expression to reduce the length of the code and to resolve the complexity, as we have already seen for the functional interfaces. Functional interface have only one abstract method, so to implement to that method we are using a lambda expression where we have writing the logic only to represent the that abstract method. Okay, so that we are writing onto the lambda expression. Understood? So now, like if we are creating a object like runnable r is equals to new runnable. So this is a wrong. What is? It is a wrong because we cannot instantiate an interface. We cannot create object and to the interface. But if we are creating like runnable r is equals to new runnable, and we have writing some logic in here. Okay, we have writing some logic. So this is not an object of runnable interface. This is an object of one of the implemented class of this interface. Okay, so this is an anonymous inner class. We have only creating an object and we are writing their logic. We are not declaring their class name. So this is an anonymous inner class. So where there is a possibility of anonymous inner class, so we are creating object and we have writing a implementation logic, we can possibility to reduce these things by using a lambda expression. Understood? Now, yeah, so going to explain how we are going to do. Take an example with anonymous inner class, how we are writing the logic with anonymous inner class and with the lambda expression. Okay, same runnable example I am taking. I am creating a class thread. Okay, in a class thread I am going to static void main. In here is string args. Okay, better I will explain onto the STS. It would be a good. Yeah, so I am creating a class, new class thread example. I am taking this one. Yeah, so it is created. Now I am going to write logic in here like runnable r is equals to new runnable This is a implemented class. So I have implemented there an implemented method. Into this method, I am writing a logic like for in I is equals to 0, I is less than is equals to 10, I plus plus in the next line. It is a child thread. Okay. Now this is completed. Now I am going to create a thread class object. Thread th is equals to the new thread, which is basically looking this runnable type of thing. And I am starting thread dot start to start this thread, newly created thread. And now I am writing a main class. Okay, main class logic for int I is equals to 0, I is less than is equals to 10, I plus plus, sorry, I plus plus. In here is I am going to write it is a main thread. Okay. So this is logic where I have created one inner class. Okay. This is a inner class. This is the class which implement runnable interface. It is a one of the implemented class. We have created object of this class and assigning to the this variable, and we are passing this variable. Okay. So here, whenever there is a possibility of inner class, so we can replace this logic with the lambda expression as well. We are writing this one. Sorry, we are running this one. So we see our output: child thread, main thread, main thread, child thread. Okay. Now I am going to write this logic with a lambda expression. So how can we going to write this logic with lambda expression? Very simple. No need to think about that how we are going to do. Okay, one method public void run. So first I am commenting this code. Okay. Yeah. So with lambda expression, what I am going to runnable r is equals to how we had write this one, new runnable. We are creating an object, okay, one of the implemented class of this interface, but we no need to write for this our lambda expression. It is a method. So we have write in here like lambda expression and the remaining logic in here. So this is this code. We can replace these things. So these two things. What I need to write for int I is equals to 0, because we are writing the implementation logic of the abstract method, right? I is less than is equals to 10, I plus plus is so child thread. I think one is more. Yeah. So now in here, I am going to create the same thing again, like thread class object, thread th is equals to the new thread. We are passing this runnable class, runnable reference, and th dot start. Okay. Now, sorry. Then main class logic for int I is equals to 0, I is less than is equals to 10, I plus plus and this so main thread. Okay, now I am going to run this thing and we can say it is the same out. So you can see that without lambda expression we have created an inner class, then we have created a implemented inner class object, and here we have then override the method and writing the logic. But we are using this thing we are replacing inner class logic with this with our lambda expression. In here we can also see in a thread class we are passing this r means reference runnable type of object. Okay, so if you see it is taking a runnable type of arguments, so that's why without of creating and passing we can replacing this logic. Okay, what we are doing, we can, so I am commenting this line as well and we can pass this thing in here, correct? Yeah, and now I am running, so this is again reducing our code, correct? So I am running, you can see it is the same example. So whenever there is a possibility to use anonymous inner class, we can or we cannot as well replace that logic with our with our lambda expression. So but we cannot say ki always we can replace inner class logic with this with our lambda expression. No, only the inner class which have only single abstract method, that inner class logic we can replace that logic with our lambda expression. Inner class can have, there are many types of inner classes, right? Like static inner class, local inner class, yeah, so there are so many inner classes like static inner class, non-static inner class, local inner classes, argument inner class. Okay, and inner class have so many abstract methods, so many concrete methods, but we can write inner class logic only, sorry, we can write inner class logic, yeah, replace that logic to the lambda expression which have only a single abstract method. Okay, and without name. So there are some changes, some differences between lambda expression and anonymous inner classes. So we just have to remember like what is the differences. So anonymous inner class, it is a class without name. So that class is known as anonymous inner class. Lambda expression, it is a function without name. That is an anonymous function. Okay, so what is an anonymous inner class? Class without name. And lambda expression, it is a function without name. That means anonymous function. Anonymous inner class can extend abstract and concrete classes as well. Lambda expression cannot extend abstract and concrete classes. Anonymous inner class can implement an interface that contains any number of abstract methods. Understood? Anonymous inner class can implement any interface that contains any number of abstract method, but lambda expression can implement an interface which contain only a single abstract method, and that interface is known as a functional interface. Understood? Single inside anonymous inner class we can declare instance variable as well, but inside lambda expression we cannot declare instance variable. Whatever variables declared are considered as a local variable. There is no concept of instance variable inside a lambda expression. Okay, so anonymous inner class, this always refers current anonymous inner class objects but not a outer class objects. Okay, but inside lambda expression this always refers a current outer class object, that is enclosing class object. So inside anonymous inner class, this this keyword is always refers the current anonymous inner class object. Whatever the current anonymous inner class, that object it is referring, but it is not referring the outer class object. But inside a lambda expression this keyword always refers the current outer class object, because there is no instance in a lambda expression, right? So this keyword is refers to the current outer class object, that is enclosing a class object. Anonymous inner class is a best choice if we want to handle a multiple methods, but lambda expression is the best choice if we want to handle interface with a single abstract method. So in which case anonymous inner class is best, in which case lambda expression is best. So if there are so many methods in there, in that case we must go with the anonymous inner class. If there is a single abstract method, in that case we must go with the lambda expression. Anonymous inner class, these objects can hold a current object, current enclosing class object, but inside a lambda expression this keyword is holding the outer class object. Okay, for the anonymous inner class, at the time of the compilation a separate class file will be generated. Okay, but for the lambda expression, at the time of compilation no separate class file will be generated. So memory will be allocated on the demand whenever we are creating an object. So lambda expression resides in a permanent memory of JVM. Understood? So these are the some differences we know between the lambda expression and with respect to the anonymous inner class. Thank you guys. Tomorrow I will go to explain much more onto the predefined functional interface, that is predicate, function, consumer and a supplier. I am going to explain more details onto that one. Thank you for watching. We'll meet onto the tomorrow session. Thank you.